Good morning.
Good morning.
So I hope you all had a good weekend. Anybody do anything amazing over the weekend? Not one. Out of 20-something students, I had not one amazing weekend. Come on. That's a little disappointing.
I went to Jackrabbit, if that counts.
Oh, yeah.
Well, let's see. Did you buy something there? Or were you just browsing?
Well, I wanted to buy moccasins, but they didn't have them in my size, so I have to get them online.
Oh, yeah.
You know, there's that, what's the name of that place in Holbrook? Holbrook Mercantile. They sell moccasins there, and they're usually a good deal. Have you tried that?
No, but I was going to go look at Geronimo, too.
Oh, yeah.
So, do you know the one I'm talking about? Right on the corner of Navajo and Hopi?
Yeah.
Should try that, too.
Okay.
Oh, yeah.
Yeah, Geronimo, I think they have them, too, so. Anybody else? All right, so it looks like everyone's there in Joe City, right? Okay, everyone there in Holbrook? Let's see, Andres, who sits next to you?
Everyone's here.
Who does?
Saucy. She's here.
Oh, okay. All right, so everyone's there. Awesome. Okay, so today we've just got a little bit to do on 6.1. And so we're going to finish that up and go into 6.2. So we are probably on Wednesday, we are going to probably just have one quiz then just on 6.1. And that'll be nice to kind of get us started. Also, I'm looking at, let's see, next Monday, I'm probably going to have that be a Moodle day where I might have a video for you to watch or a quiz to take, depending on kind of where we are. But that's kind of the plan for next Monday. So, and we'll talk about that more later in the week. Let's see, where were we? All right, I think we were on that last part about angular speed. Yeah, there we are. Arc length and angular speed. So let's, if you want to turn there in your guided notes. Okay. So arc length and angular speed. This is the part that a lot of the trig that we've talked about thus far, you could have seen in an Algebra 2 or geometry class. Typically, you won't have seen this unless you've had physics. So if you've had physics, this might come back to you. But arc length and angular speed. So there's a couple of formulas and that use radians. And so this is kind of the idea, is just to practice plugging in the radians into the formula. So the first one is to find the length S of a circular arc of radius r and central angle theta measured in radians is S equals R times theta. So this is the formula, but the angle has to be given in radians. So if it's not in radians, then the first thing you have to do before you plug into the formula is convert it to radians. Okay? So what is an arc length? Well, it's, imagine, you're eating pizza let's say Mr. G's Pizza from Joe City because that's the best. But anyway, so the arc length is like the crust, okay? So the crust, the outside distance is the S. So the R is the radius, and then the theta is the angle in radians, not degrees, okay? So S equals R theta. That's the formula. All right. So let's say that it says to find the arc length S. Okay. So we're trying to find S. We know R. We know theta. So S equals R theta. That's what we're going to use. We're going to plug in 3 for R and pi thirds for theta. And then here the 3's cancel. So your answer is just pi. Now the units for S and the units for R are always the same. So since the radius was given in inches, then the S is going to be in inches here too. So pi inches would be this length right here. Okay. Any questions on that? All right, so let's have you try practice 4A, please. All right, so Andres, when you've got it. So Andres, do you have it or are you stuck?
I'm stuck. I don't know how to do this.
Okay, so the formula is S equals R theta. So R is the radius and it tells you is 5. So you plug in 5 for R. The angle is pi thirds. So you plug in that for the theta. And then it's just 5 times pi thirds or 5 pi thirds. Okay, don't even need a calculator for that. And the units are in inches, the same as the units for the radius. Okay? Now, if you had 5.235 or 5.236, that's okay. But just know that I'm probably going to have pi in my answers, okay, on these. All right? Any questions on that? Okay, so now let's say that you're given the angle in degrees, okay? So the first thing you have to do is, before you plug in to the formula S equals R theta, you need to convert the angle to radians like we did last time. So you say, all right, well, remember to convert from degrees to radians, you multiply by pi over 180. Then reduce the fraction, and so that would be 4 pi thirds, or if you just put it all in your calculator, 4.189. Okay. Now, so either way is fine. Either way is, so that's what you're going to plug in for theta. So if you plug in 240, you're going to get the wrong answer. Okay? So now, S equals R theta. So S equals 4, the R is 4, times 4.189 or 4 pi thirds. You do it either way. And so the nice thing about this is that you don't have to use a calculator. If you leave it as a fraction, you just get 16 pi thirds, and that's cool. Or you put it in your calculator, 16.755. But either way, it's in inches. All right? Any questions? All right, go ahead and try practice 4B, please. All right, so Jocelyn, when you've got it.
Okay, so for my final answer, I got 24 pi.
24 pi. 24 pi is correct. And the units would be in inches. Okay, great job. Any questions on that? Anybody like me to go through it?
Can you go through it?
Sure. Okay, so the first thing you have to do is convert your 160 degrees to radians. Okay? So 160 times pi over 180. All right? Then you use the formula that I gave you, S equals R theta. So you're going to plug in, let's see, R is 27, and your theta is 8/9 pi. And so then 3, let's see, well, 9 will go into 27 3 times. 3 times 8 is 24, so 24 pi. Okay? All right. Let's see here. All right, any questions? All right, great job, Jocelyn. Okay, let's see. Now let's just go on to the next one. Okay, if theta is the angle in radian measure corresponding to the arc length s, then the angular speed of the particle, and this little W-looking thing is actually omega, is the Greek letter omega. Now the capital omega looks like this, and typically if you draw like a W with wings on it, that's kind of how normal people write it. If you don't have some cool font that makes it look like the Rebel Alliance and Star Wars symbol or something. Okay, but anyway, but the formula for angular speed omega is theta divided by t. Okay, so angular speed, so you imagine the angle that the thing is going through divided by time. And sometimes you'll have it, can you think of something in real life that has an angular speed? let's see. Seth, you're my mechanic, right? Aren't you the mechanic?
I try to be.
Okay, so what on a car is measured has an angular speed? What? So, but instead of so the angle of 2 pi, they just in a car they just say 1 revolution.
Oh, so the engine?
So the engine, the RPMs is an angular speed. It's revolutions per minute. That's what RPM stand for. Okay, so so when we talk about the theta, the angle is 1 revolution or 2 pi radians, and then per minute. So that's an angular speed. Okay, it's like how fast it's turning. Okay. All right, now, so consider a particle moving at constant speed along a circular arc of radius r. If s is the length of the arc traveled in time t, then the linear speed of the particle is v equals s divided by t, so the arc length divided by t. Well, and so that's, remember s is r times theta, so it's r times theta divided by t. So imagine if you have see if you're trying to figure out like how fast the wheels of a car are moving, does that tell you how fast you're going? How fast the wheel is turning? See, how fast the wheel is turning, that doesn't necessarily give you your linear speed. So what they do is you actually calculate how many for every revolution. And so, well, let's just compare these formulas. So angular speed is the angle divided by time. Linear speed, if you already know the angular speed, how would you get the linear speed?
Multiply theta by the radius? I don't know.
Multiply by the radius. Okay? So if you have the angular speed, if you multiply by the radius, it gives you your linear speed. Okay? So, so like with a car, to calculate the linear speed, the car actually uses the manufacturer's recommended radius for the wheels. So have you ever heard of like people that like, let's say they go get like monster wheels on their truck or whatever, and it actually throws off the speedometer? Any of you ever heard of that? Well, this is why. Because the linear speed, the miles per hour, is computed using the radius of the wheels. So if you change the radius of the wheels, your car is going to register the wrong speed. And so, you know, you could maybe get away with it. Cop pulls you over once and you just say, I just changed out my tires. You know, I probably threw it off. Sorry. Maybe you can get away with that once. I don't know. But
So I want to make sure I actually understand this. So, like, if you have, like, a baseball and a basketball, and they're like spinning at the same speed as they're rolling, but the basketball has a bigger radius, it's going to move farther in the same.
So, like a dot on the basketball would travel farther.
Okay.
Than a dot on the baseball.
Yeah.
So even though if they're spinning at the same rate, their angular speed is the same. But their linear speed, that dot is actually traveling farther. So yes. Okay. Thank you for that question. Okay. Wait. Okay. So angular speed we're going to do angular speed and linear speed, okay, in practice 4C. So what we're going to do is whenever you have to find both of them, you're better off just finding the angular speed first. Because like Avery said, all we have to do then is multiply by r to get the linear speed. Okay? So it says the second hand of a clock is 8 centimeters long. So that's like the radius. Find the angular speed and the linear speed of the tip of this second hand. Okay? So here's the second hand. So it makes one revolution. It would be what angle? One revolution is what angle?
360.
Right, except these formulas, we want to be in radians. So how many radians is that?
Is it 2 pi?
2 pi, okay? Great. So one revolution. So it makes one revolution, or 2 pi radians, in how much time?
A minute.
1 minute, or 60 seconds. So you can compute your angular speed in radians per minute or radians per second. Either way, okay? So what you would do is then you would say that, let's say you do it in radians per second. So you say your angular speed is the angle that it makes. So all the way around is 2 pi radians in 60 seconds. Okay? So then we reduce that fraction and we would get pi 30ths radians per second. Okay? So everybody cool with that? All right, so now I want you to compute the linear speed. So if there was a dot at the end of that second hand, the second hand, how fast is it going? The tip. All right, Jill, when you've got it.
Is it 4/15 pi radians?
That is correct. 4/15 pi or 4 pi 15ths, either way. And the units are going to be centimeters per second. Now you might say, wait, what happened to the radians? Well, what happens is that when you convert it to linear, then you use the same units as the radius. Okay. So here where the radius was given is 8 centimeters. So you would use centimeters per second. Now, if you put that in the calculator, you got 0.838, that's fine too. Okay. So you take your answer for your angular speed and multiply it by 8. And then you use whatever the units are for the 8 over the seconds. Okay, so that's why it's centimeters per second and not radians per second. So the radians per second, that's for your angular speed. The linear speed would be on a line how fast it would be going. Okay. All right, any questions on that? Okay. All right, next, for the area of a circular sector, okay, the book, well, most books, because we're dealing in radians, they actually give this second formula. I'm actually giving you two different formulas because really what you use, you can have the angle be in degrees or radians on this, okay? So you could have, if you're given the angle in degrees, then you divide by 360, and then it's times pi r squared. If you're given the angle in radians, then it's that over 2 pi times pi r squared. So,
Mr. Strong, I have a
yes.
question.
Yes,
So when
please.
you have the x and then the little r, does that just mean x number of radians?
Yes.
Okay, 'cause it
So
looks like
in radians. So if you're given it in radians, then you just divide by 2 pi. If you're given it in degrees, divide by 360. Basically what you're doing when you're finding the area of a sector, it's kind of like a slice of pizza. Okay? So instead of finding the area of the whole pizza, which would be pi r squared, what you're doing is this part right here that is figuring out what fraction of the pizza you're eating. Okay? So this says, okay, maybe I'm eating a third of the pizza, and then the pi r squared is the area of the pizza. So the angle tells you what fraction of the pizza you're eating, and then the pi r squared would be the area of the whole thing. Okay? So yeah, so usually you don't have the little r when you're given the angle, but just know if it's in radians, divide by 2 pi. All right? So this is determine the area. So here we want the area of the sector. So that's kind of the slice of the pizza. If the circle is of radius 3 centimeters and a central angle of 52. So again, I give you the other formula so you don't have to convert it. You could just say, all right, I'm going to take 52 divided by 360, and then it's times pi r squared. Okay? Now, so you can leave the pi out and just simplify the rest, or you could just put the whole thing in, however you want to do it. I just kind of like to leave things. The nice thing about fractions is that you can get an exact answer. So here I divided 9 into 360 and got 52 over 40, which then 4 goes into that, 13 over 10 pi. And then since we're talking about an area, it's units squared. Okay. All right. Any questions on that example? Okay. So then, if you're given the angle in radians, then it's the angle for here. Find the area of a sector of a circle of radius 1/2 a foot, central angle 4 pi thirds. So you take your 4 pi thirds divided by 2 pi, since it's in radians this time, and then it's times pi r squared. And so then you simplify out. The pi's are going to cancel. A half times a half is a fourth. Let's see. So you can get the 4's to cancel, pi's to cancel, and so you're left with pi 6. And then since the units were feet, it's square feet because it's area. Okay? So I almost think it's easier to, if you've got a pi in there, just to leave it in there. But if you want to do it in the calculator, that's okay too. All right, so go ahead and do practice 5, A and B, and then we'll go over those. All right, so Taylor, when you've got the first one.
Is there a Taylor and Holbrook?
Yes.
Or, oh, okay.
Taylor.
There's no
Taylor
Taylor in Holbrook.
Oh, well, why do I have that on my...
Yeah, Taylor Fields isn't in this class anymore.
Okay. All right. So what have I done here? Oh, I know what it is. Okay, so Taylor's older sister is Madison, and there's a Madison in Holbrook. So that's how my brain worked. All right, so Madison. That's kind of funny.
2 pi.
2 pi is correct. So 2 pi, and go ahead and write in the units, which would be square centimeters. Okay? So good job on that. And Avery, how about B?
Can you help me with that, please?
Okay. So, so you take the angle, and since it's in radians, what do you divide by?
2 pi r or 2 pi?
Just 2 pi. So take pi thirds divided by 2 pi, and then it's times pi r squared. And so the radius here is 1/4. So that's what you're going to square. So the area is going to be pi thirds divided by 2 pi times 1/4 squared. So you can either give me a exact answer or a decimal answer.
Okay, so I got 0.323, but I don't think that is correct.
That is correct. Okay. So the pi thirds over 2 pi, I just canceled the pi and canceled the, oh, no, I just rewrote it. Pi thirds, dividing by 2 pi is the same as multiplying by 1 over 2 pi. And then 1/4 squared is 1/16. So when you write it out like this, it's a little easier to see. Okay, pi's are going to cancel, and that's pretty much it. So then you'd have pi over 6 times 16, which is 96. So you could have your answer be pi 96, or the decimal, but it's square feet.
Or yeah.
Which pi's cancel?
Well, one of the ones on top with this one in the bottom. I mean, you can cancel whichever one you want. All right. Any other questions on that? Okay, so that's it for 6-1. So we will have our first quiz on Wednesday during class time. However, and this is going to be a point of emphasis this semester, is if you feel like that you would prefer to go to tutoring, then you just email me, talk to your talent aide about scheduling your quiz another time. And you are always, always welcome to do that. Okay? So if you feel like you need another day or two to study, that's great. You can do that. Okay? But then you have to come to tutoring. If you don't go to tutoring, and then you'll get a 0 on the quiz. Okay? So I'm not just giving you extra time. Okay? So you have to come to tutoring if you're not going to take the quiz. Okay? So, but we're just right now. So on Wednesday we're just going to have one quiz. So on 6-1, you're going to get 2 attempts, but it's going to be randomized a little bit. So each of your 2 attempts might be slightly different. Okay? And I'm going to just try it out. I'm going to give you the highest of your 2 attempts, the highest score. Okay? So we'll see how that works. Okay? Now, I will tell you straight up, if I hear about any student sharing answers or cheating in any way, then I'm not going to do the highest score ever again. Okay? So I'm just putting it on you and on the honor system. But if I hear anything about sharing answers or whatever, I'll just put it into it. But I want to do the highest grade because I think that, number one, it could do nothing but help your grade. Okay? And I think it would help you because you would have a little more incentive to even study a little bit more for the second attempt. Okay? So, maybe take the first attempt, bone up on a couple of problems before you take that second attempt. Anyway, that's kind of my thought. All right?
Mr. Strong, I have a question.
Okay.
So if they decide they want to do the tutoring on Wednesday instead of the quiz,
Uh-huh.
do they have to go to Holbrook to do the tutoring?
No. Mr. Fritz does the tutoring, the broadcast.
Yes. So they would be doing the tutoring in the same classroom as the kids that want to do the quiz?
So then you would want to just send the people taking a quiz into the next room or send them to the library or something.
Okay.
Yeah,
All right, thank you.
Yeah, that's a good point. Yeah, we don't want to be in the same room quizzing while Mr. Fritz is answering questions on it. So
okay.
Thank you for that clarification.
No problem.
Okay. All right. Any other questions? Okay, great. So I don't see Mrs. Smith in Holbrook. So you guys tell her, and I'll tell her as well, that if we have some people that want to do tutoring, then you guys can do your quizzes in the library. But again, it's not a cooperative effort. You need to set at separate tables. You're not comparing answers or whatever. Okay. All right. So let's go on to 6-2. All right, so 6.2 is on trigonometric functions of an acute angle. Now this is usually geometry teachers do a good job of presenting this aspect of trigonometry, of acute angles. So we're going to talk about the 6 basic trig functions, and then how to evaluate, and then applications. And so this is a very important section. And while I say I'm hoping that it'll be a review of probably, anyway, I'm going to teach it from the ground up. So if you don't remember it or whatever, I'll try to help you as if you hadn't had any of it. Okay, so when I talk about the 6 basic trig functions, these are they. Okay, So these are the abbreviations. So the six trig functions are sine, cosine, tangent, cosecant, secant, and cotangent. Now, and for all of them with one exception, the abbreviation is just the first three letters. Okay? So why do we have to be so tricky with cosecant?
It has the same first three letters as cosine.
Right, because COS is already taken. So we use CSC for cosecant. Okay? But otherwise it's just the first three letters of the function. Okay? Now, what they are is the six trig functions are just the ratios of two given sides of a right triangle. Okay? And so you have the hypotenuse is the longest side, and then the other two, opposite and adjacent, are really depending on which angle you're coming from. So if you're coming from this angle, then the adjacent side means next to. Well, this is also next to it, but the longest side, the side opposite the right angle, is always the hypotenuse. Okay? And so then from this angle, this side is adjacent, this side is opposite. Okay? Now, coming from angle B up here, then these two would switch. Okay? That depends on what you're coming from. All right. Let's see here. There's something. Okay, so let's start with this. So the definitions of the six trig functions. So in terms of those sides, okay, the sine is the opposite side over the hypotenuse. The cosine is the adjacent over the hypotenuse. And then the tangent is the opposite over the adjacent. Now, I'll let you go ahead and write down the other three, and then I'll talk about that. Okay, so really and truly, I mean, I've been teaching trig for a lot of years, and I really only memorize the top row, okay? And the way I memorize it is SOHCAHTOA. And so if you haven't heard of SOHCAHTOA, the spelling is really important. And because it helps you remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So I had one student that kept messing up on this, and come to find out he had misspelled it wrong in his notes. And so he's getting the wrong sides, okay? Now, when I was a department head in South Carolina, I would go and visit the other teachers, the other math teachers, and kind of see how they were doing and how their classes were going. Anyway, and there was this one teacher that had been teaching since, the 60s or 70s, okay? And so she was teaching this lesson, and I had always used SOHCAHTOA, and sometimes I'd make up silly stories about it. some Indian princess named Sokotoa or something or whatever. Some silliness. But the way that she taught it was some old hippie caught another hippie tripping on acid. And I was like, I don't know if we want to talk about drug use in a geometry class, but you know what? It helped her students memorize it, so I didn't worry about it too much. But I just remember Sokotoa. All right, now, okay, then the other thing that I remember is what the reciprocals are, okay? And so here we need to know that the cosecant is the reciprocal of the sine. So when we say cosecant is 1 over sine, that means cosecant is the reciprocal of the sine. And secant is the reciprocal of the cosine. And cotangent is the reciprocal of the tangent. Okay? So we need to know those. And so I don't memorize that cosecant is hypotenuse over opposite. I just find the sine and then flip that fraction. Okay, so you'll kind of see how I do that in just a second. But we need to know these reciprocal identities. Okay. Now, okay, so then as a trig student, I remember taking a quiz on this and I bombed it. And what it was is I always thought that secant, I initially thought that secant went with sine and cosecant went with cosine. That just seemed logical to me. But it doesn't work that way. Okay? Sine doesn't go with secant. Sine goes with cosecant, and cosine goes with secant. So I just remembered, okay, it just goes the opposite of what I think it should. Okay? All right, so now, so let's say we have this triangle, and we want to find all the trig functions, and we're just given 2 sides of the triangle. Well, in order to get all 6 trig functions, you have to know the third side. And so usually you're going to use the Pythagorean theorem to get the third side. Okay? So here, from angle theta, I know the opposite side is 4, the adjacent side is 3, and then I use the Pythagorean theorem to get that the hypotenuse is 5. Okay? So everybody cool with that? All right. So now you go through and you say, okay, so let's find all the 6 trig functions from angle theta. So you say, okay, the sine is the opposite over the hypotenuse, so that would be 4/5. So then I jump right to the cosecant then and say the cosecant is the reciprocal of that, so it's just 5/4. So you just flip the fraction. Okay, the cosine is the adjacent over the hypotenuse. So so that would be 3/5. And so then the secant is just the reciprocal of that, so 5/3. Finally, the tangent, TOA. The tangent is opposite over adjacent, so 4/3. And so then the cotangent, you flip that, adjacent over opposite, so it'd be 3/4. All right? Any questions on that? All right, so go ahead and do practice 1, please. All right, Desiree, what's the hypotenuse here?
13.
13. Okay, you got to get that right. If you get that wrong, you're going to miss like 4 out of the 6 problems. So you got to make sure you get 13 right. So any questions on that? Okay. All right, Raylyn, what's the sine of theta?
12 over 13.
12 over 13 is correct. So then what's the cosecant? Raylyn?
13 over 12.
Excellent. All right, Hannah, what would be the cosine?
5 over 13.
5 over what?
13.
And what would be the secant?
Yeah, that's lucky. 13 over 5.
13 over 5. Okay, so we got less than a minute. So anybody, what's the tangent?
12 over 5.
12 over 5.
12 over 5. And then the cotangent would be? Anybody?
5 over 12.
5 over 12. Great job, everybody. So we'll pick